In this video, we're going to talk about vectors. So what's the difference between a scalar and a vector? A scalar is a quantity that has magnitude only, and we have examples like speed, distance, age, while a vector has both magnitude and direction. For example, velocity, acceleration, force. Now, any vector has a beginning and an end point. It also has a direction and a magnitude. Now, we can represent a vector in a two-dimensional by using the axis, the y-axis and the j-axis. So B is the projection on the j-axis and A is the projection on the y-axis. Now, how do we draw vectors? Suppose we want to draw the vector 5a minus 2j. So we're going to go on the x-axis to the right 5 units. Then we're going to go down 2 units on the y-axis or the j-axis. And where we stop, we're going to connect that point with the origin. So this is 5i minus 2j. Another example, if we want to draw negative 3i plus 6j, so we're going to go to the left 3 units on the x-axis or the y-axis, then up by 6 units on the y-axis or j-axis. Where do we stop? We're going to connect that point with the origin. Now, if I want to draw 2i, it's just to the right 2 units on the x-axis, or negative 3j is down 3 units on the y-axis. Comparing vectors, we have vectors that have the same magnitude but different direction. Also, we have vectors that have the same direction but different magnitude. Equal vectors have the same magnitude and direction. When we multiply a vector by a scalar, we call that the product of a vector by a scalar. So any vector multiplied by a scalar, it means each component is multiplied. For example, 3 times 5i minus 2j, that's 15i minus 6j, and negative 2 times 3i minus j, that's negative 6i plus 2j. So if we took the vector 3i minus j, and this one, negative 6i plus 2j, notice the blue one is twice the pink one, and the pink one is in a different direction because it got multiplied by a negative. Operation on two vectors, we have the addition. We add the I components and the j components. We have the subtraction, and we have the dot product. And always the dot product of two vectors is a scalar. We're going to start with the addition of two vectors. So we only add the i's and the j's. So 3 minus 2i, that's 1, and 4 minus 6, that's 2. Another example, 10 minus 7, that's 3, and 6 plus 9, that's 15. Subtraction of two vectors, we're going to change the sign of the v vector. Now we can add them. So 3 plus 2, that's 5, and 4 plus 6, that's 10. Another example, we're going to change the sign of the second vector because we're negating every sign. Now we can add them. 10 plus 7, that's 17, and 6 minus 9, that's 3. Now the dot product is 3 times -2 plus 4 times -6. Keep in mind, I times I is 1 and j times j is 1, where I times j is 0 and j times I is 0. So that's why the product of two vectors is a scalar. Now, if the dot product of two vectors is 0, then the vectors are perpendicular. So if we took these vectors, if we took their dot product, notice is 0, so we can conclude that they are perpendicular. The magnitude of a vector is represented by the square root, and we square the components. We take the sum of the square of the components. So we're going to see examples. Now the angle between two vectors is represented by this formula. And we're going to see an example. Parallel vectors. If we multiply a vector by a scalar, the result is another vector, and these two vectors are parallel. So in this example, u and v are parallel. Another example. Another example, u prime and v prime are parallel.